So in the previous class we discussed up to question number 39. So the right answer would be option D, internal energy. So question number 40 is a Carnot engine operates between 27 degrees centigrade and 327 degrees centigrade. If the engine produces 300 kilojoule of work, then what is the entropy change during heat addition? So we have to solve this. So the temperature limit given 300 Kelvin and that is 600 Kelvin. So entropy equation Q by T1 is equal to Q by T2 implies that Q1 minus Q2 divided by Q1 minus T2, which is also equal to W by Q1 minus T2. Next, efficiency is equal to W net divided by Q1 and W given 300 kilojoule. This is 300 and Q1 we have to count, and also efficiency for reversible is 1 minus T lower, which is 300, and T higher 600, which is equal to 1 by 2 is equal to half. So Q1 is equal to 600. So the entropy in a system is equal to Q1 divided by T1. Q1 is 600 and T1 is, that's mean T higher, equal to 600 is equal to 1, is kilojoule. So answer will be 1 kilojoule per Kelvin. Option B is the correct answer. Next, question number 41. For a reversible power cycle, the operating temperature limit are 800 and 300 Kelvin. It takes 400 kilojoule of heat, and we have to find the unavailable work. So given the upper limit, (800), which is TH, and the lower temperature limit is 300, and this is the heat engine which produce W by rejecting Q2 and accepting heat Q1. So efficiency we know 1 minus T lower by T higher, which is equal to W divided by Q1. So 1 minus T lower 300 and T higher is 800, and W and Q1 given 400 kilojoule divided by 400. So 1 minus 3 by 8 into 400 is equal to W, which is also equal to W available. 1 minus 3 by 8 is equal to 5 by 8 into 400, which is equal to 250 kilojoule is equal to W available. Unavailable energy is equal to Q2. That means the heat which reject rather using producing work. So Q2 is equal to Q1 minus W available. Q1 given 400 and the W available is equal to 250 is equal to 150 kilojoule. Answer will be 150 unavailable energy. And B is the correct answer. Next, the specific heat of an ideal gas depend on temperature only. Next, an insulated box containing 0.5 kg of gas having specific heat at constant volume Cv value is equal to 0.98 kJ per kg Kelvin falls from a balloon 4 kilometer above the Earth's surface. And what will be the temperature rise of the gas when the box hit the ground? So conservation of energy we have to apply. It is the potential energy. mgh is equal to mcb delta t, and delta t we have to found, and cv value 0.98, and mass given, mass cancel, no need to put the mass, and the g value is 9.81, and the height is 4 kilometer, convert into meter, 4 into 10 to 3 meter, and cv is 0.98, and delta t we have to found that what will be the temperature rise, that means temperature change. So putting the all the value, and temperature rise will be delta will be 50.04 Kelvin. So right answer will be option C. And 0.98, this unit is kilojoule per kg Kelvin, so convert into joule, so we have to put 10 to 3. So putting all the value, we can get answer will be 40 Kelvin. Next question number 44. Compared to a standard cycle in actual working, the effect of variation in specific heat is 2. So as compared to air standard cycle in actual working, the effect of variation in specific heat is to reduce maximum pressure and maximum temperature. Option B is the correct answer. Next, the number of degree of freedom of diatomic molecule is. So the number of degree of freedom of diatomic molecule is option D, 5. Next, with increase of pressure, the latent heat of the steam decreases. Option C is the correct answer. When wet steam flow through a throttle valve and remains wet at exit, then its temperature decreases but quality increases. Option B is the correct answer. Next, question number 48. Variation of pressure and volume at constant temperature are the correlated through. So here given constant temperature, variation of pressure and volume. So this is the Boyle's law. Charles law, pressure constant. Boyle's law, temperature constant. So option B is the correct answer. Next, an industrial heat pump operates between temperature 27 degrees centigrade and 13 degrees centigrade. The rate of heat addition and heat rejection is 750 and 1000 watt respectively. The coefficient of performance of heat pump is. So given data is 27 degrees centigrade and 13 degrees centigrade. Let's convert it into Kelvin. And heat addition is 750 and reject it 1000. So I have to find the coefficient of performance of heat pump. So given the temperature limit, the higher temperature limit 300, that means 27 degrees centigrade, which is TH in Kelvin, and heat rejected is Q2 is equal to 1000 watt, and this is the heat pump, and set Q1 and the lower limit is 286 and given W in we have to found and Q1 is 750. So from manually balance Q1 plus W in is equal to Q2. So Q1 is 750 and W in equal to 1000. So W in will be 1000 minus 750 equal to 250. W in equal to 250 and COP coefficient of performance of heat pump will be TH divided by is not reversible, so we don't add the temperature. So the coefficient performance is refrigeration effect, that means see the refrigeration effect Q2 divided by work input W in. So Q2 is 1000 and W in is equal to 250, which is equal to 4. So answer will be 4. And C is the correct answer. Next question. It is proposed to build a refrigeration plant for cold storage to be maintained minus 3 degrees centigrade and the ambient temperature is 27 degrees centigrade. If 5 into 10 to the power 6 kilojoule per hour of energy is to be continuously removed from the cold storage, then the minimum power required to run the refrigerator. So minimum power, that means we have to convert into reversible. So let's solve the question. So given data is TH is 300 Kelvin, C refrigerator which require W in and Q in is given 5 into 10 to the power 6 kilojoule per hour. So convert into second, 60 minute, 60 second. So the lower temperature is 270 degrees centigrade minus 3 degrees centigrade and is equal to 270 Kelvin. So COP is equal to refrigeration TL divided by TH minus TL. So TL is equal to 270 divided by TH minus TL, 300 minus 270, which is equal to 270 minus 30 is equal to 9. So COP of refrigerator is equal to Q in divided by refrigeration heat the refrigeration effect divided by W in. We know that COP of refrigerator for reversible for obtaining maximum work, W in equal to minimum power and COP given 9 and Q in is equal to 5 into 10 to the power 6 divided by 60 into 60 divided by W in. So W in equal to 5 into 10 to the power 6 divided by 60 into 60 into 9. So the answer will be 154.32 kilowatt. So answer option C is the correct answer. Next, air cooling is used for fan compressor where water ejaculation adapted for cooling ammonia compressor. This is because latent heat of ammonia is higher than the. So option A is the correct answer. Latent heat of the ammonia is higher than freon. Next, question number 52. A single stage vapor compression refrigeration system cannot be used to produce ultra low temperature because volumetric efficiency decreases considerably. Next, excessive pressure drop in liquid line in a refrigeration system causes flashing of liquid refrigerator. Next, which of the following refrigerant has maximum ozone depletion in the stratosphere? So maximum ozone depletion in stratosphere causes fluorine. Next, In milk chilling plant, the usual secondary refrigerant is brine. Option D. Next, the leaks in the refrigeration system freon are detected by a Haldia torch, which is on the detecting producing greenish flame lighting. And sulfur stick used for NH3 ammonia. So option A is the correct answer for refrigeration system. The leakage detection of the freon, which is usually done by Haldia torch, which is detecting producing greenish flame lighting. Next question. Which one following the refrigerant has the highest critical temperature? So water has the highest critical temperature. And is the correct answer. Next question number 58. A furnace is made up of red brick wall of thickness 0.5 meter and conductivity 0.7 watt per meter Kelvin. For the same heat loss and temperature drop, this can be replaced by a layer of diatomite earth of conductivity 0.14 watt per meter Kelvin and thickness will. We have to find the thickness for same heat loss and same temperature drop. So let's solve the given data. Thickness of one first material thickness is 0.5 meter and thermal conductivity K1 given 0.7 watt per meter Kelvin. Next we have to convert it the second diatomite at of conductivity given A2 is equal to 0.14 watt per meter Kelvin, and we have to find thickness and the condition given, the temperature difference is same and the heat loss is same. So from Fourier law of conduction, Q is equal to K area dt divided by thickness. So area is constant and temperature difference is same and Q is also given same. So the remaining K and T. That means K1 by T1 is equal to K2 by T2. Putting all the value, K1 given 0.7, T1 given 0.5 is equal to A2 0.14 and T2 have to found. So T2 is equal to 0.7 and 0.14 equal to 0.2 and T2 is equal to 0.2 into 0.5, which is equal to 10 divided by 100, which is equal to 0.1 meter. Option B is the correct answer. Next, question number 59. A composite wall having 3-layer thickness 0.3 meter, 0.2 meter and 0.1 meter and thermal conductivity are 0.6, 0.4 and 0.1 watt per meter Kelvin respectively, is having surface area 1 meter square. If the inner and outer temperature of the composite walls are 1840 Kelvin and 340 Kelvin respectively, then what is the rate of heat transfer? Same as in the previous formula. To apply, Q is equal to del T by del X, which is also written as del T by thermal resistance. So this is the series connection. given the composite wall having thickness 0.3 meter, 0.2 meter, 0.1 meter, and thermal conductivity given 0.6, 0.4, and 0.1. So Q we have to found, and the temperature difference is 1840 and 340. So the temperature difference is 1840 minus 340 divided by the thermal resistance. Thermal resistance is thickness and conductivity into area. So the thickness first layer is, this is series connection, 0.3 divided by 0.6, and the area given 1, so no need to put the value 1. So next series connection, and the thickness of second layer 0.2 divided by conductivity 0.4. Next 0.1 thickness and conductivity also 0.1. So 1840 minus 340, we get 0, 0, 1800 divided by 1 by 2 plus 1 by 2 plus 1, 1800 divided by 1 by 2, 1 by 2, 112 equal to 750 watt. So the right answer will be D, 750 watt. Next, the effectiveness of a fan will be maximum in environment. So we know the formula, effectiveness is equal to root over AP by HA. So effectiveness is directly proportional, inversely proportional to 1 by convective heat transfer coefficient, provided the conductivity and area and perimeter is constant. So effectiveness is usually effective where H value is minimum. So where H value is minimum, free convention, H value minimum, so the effectiveness will be maximum in free convection. Next question number 61. Fins are made thin as possible to accommodate more number of fins. 61. Answer will be B. Next question number 62. The ratio of energy transfer by convection to that of conduction is called as. It is called as Nusselt number. Next question number 63. The tendency of petrol to detonate in terms of octane number is determined by comparison of fluid with which of the following? It is comparison with mixture of normal octane and isoctane. Option B is the correct answer. Next, knocking tendency in SI engine reduces with increase in engine speed. Option D is the correct answer. Next, the volumetric efficiency of the well-designed SI engine is the range of 70 to 90%. Next question number 66. The delay period in CI engine depend upon which of the following? So the temperature and pressure in the cylinder are the time of injection. This is correct. And nature of fuel mixture strength. It is also correct. Relative velocity, the fuel injection, and air turbulence pressure of the residual gas. So answer will be option D. All of those. All of the above. Next question number 67. The knocking tendency in the compression ingression engine increases with so the knocking tendency in compression ingression engine increases with decreasing compression ratio. So by decreasing compression ratio, knocking tendency increases in case of CI engine. So option C is the correct answer. Next, If the performance of diesel engine of the different size, cylinder dimension, power rating are to be compared with, which of the following parameter can be used for such comparison? So specific brake fuel consumption is the parameter which is compared with different size, cylinder dimension, power rating. So option C is the correct answer. Next, a four-stroke diesel engine when running at 2000 rpm has injection during has injection duration has, in, has injection duration of 1.5 millisecond. What is the corresponding duration of the crank angle in degree? So the time is alpha by 360 into 1 by n. This is revolution per second up to mention. So the time given 1.5 millisecond into 10 to the minus 3, and alpha to found 360 degree into n given 2000 revolution per minute. So convert it second. So after calculating, we get alpha will be 18 degree. So option A is the correct answer. Next question number 70. Divided chamber diesel engine are use lower injection pressure compared to open chamber diesel open chamber engine because high air swirl does not require high injection pressure for atomization. Option B is the correct answer. In some carburetor, meter rod and economizer devices is used for power enrichment. Option C is the correct answer. Two reference fuel used for Assitant rating is cetan and alpha methyl naphthalene. Option D is the correct. Next, in electronic power steering, the torque sensor is nothing but magnetic effect sensor. Next, in automobile ignition system, the ignition component that step up the voltage is ignition coil. Next, pitching moment is influenced by dash in the moving vehicle. Lift force in the moving vehicle. The spark plug gap can be checked by filler gauge. Next, the venturi in the carburetor causes increase in air velocity. Next, question number 78. In a disc brake, the disc is attached to the axle. Next, in 79, in four-stroke cycle diesel engine, the exhaust valve open at 30 degree before bottom dead center and close at 10 degree after dead center, top dead center. So option A is the correct answer. Next, question number 80. The function of charging system in an automobile is to supply electric power. Next, which one following is the mounted between engine and gearbox? The mounted between engine and gearbox is clutch. So C is the correct answer. Next, overdrive is provided in the transmission of vehicle to improve fuel consumption. 82, option B is the correct answer. Next, 83. The load supported by an automobile frame is weight of the body, passenger and cargo, torque from engine and transmission. C, sudden impact from collision. D, all of the above. So answer will be option D, all of the above. Next, the angle between steering axis and the vertical in the plane of wheel is called caster angle. Next, 85. Which of the following clutch arrangement is used in synchronous gearbox? So this is called dog clutch. Next, the main function of gearbox is to vary the torque of the vehicle. Option D is the correct answer. Next, a hook's joint is used to connect non-coplanar and non-parallel shaft. B is the correct answer. Next, The pressure gauge G1 and G2 are installed in the system shown in the figure. The gauge pressure of G1 given 5 bar and the gauge pressure of G2 is 1 bar and the value of honor pressure P. So here the atmospheric pressure is not given. So let take atmospheric pressure is 1.01, which is universal. For this chamber, the pressure will be 1 plus 1.01, which is equal to 2.01, and for this chamber, this gauge pressure and this summation will be the atmospheric pressure. So 5 plus 2.01, which is equal to 7.01. This is the absolute pressure. So the right answer will be 7.01. Option D is the correct answer. Next question number 89. From the next class, we discuss from question number 89, which is a probability. So thank you.